Welcome to the NJIT website and math podcast. My name is Vanessa and today I'll be covering like radicals. So what are like radicals? Radicals that have the same index or the same radicand are referred to as like radicals. And just as a reminder, what an index is if you have a radical, doesn't really matter what the root is, but if you have a radical, the expression or number that's inside of the radical is what's referred to as the index. So when you have the same index in different radicals and you're performing addition or subtraction, if you have the same index, then you can add them or subtract them. Kind of like the same concept as a common denominator in subtraction or adding fractions. So let's just do some examples with that. So say we had this example. Square root 45 plus 7 square root 20. Okay, naturally we don't have the same index here right now because one index is 45, the other one is 20. But we can use the distributive property to pull out perfect squares or perfect roots in order to get the same index. So let's try to simplify each. So with the first one, square root of 45, how can we break that up? We can break that up into, and try to keep in mind you want to use factors that are, because in this case we're dealing with square roots, so we want to deal with perfect squares. In this case, our perfect square would be 9 times 5, right? Because 9 is a perfect square. Okay, the square root of 9 is 3, so that automatically comes out of the radical. And then the square root of 5 is what's left. Let's see what we can do with the other one. Square root of 20 can be broken up into what factor can be a perfect square? 4 times 5. So I'm going to repeat that 7 and write this as 4 times 5. And the perfect square of 4 is 2. So the 7 stays, and then whatever comes out also needs to be multiplied. So it's technically multiplied times 2. And we still have the radical 5, and there's a plus sign in between. So now we have the same index. Both are just now a radical 5. So now you want to simplify the right-hand side once more by multiplying the 7 times 2, which is 14. And then we have radical 5. And then now because they have the same index, we can just add across. You don't add the radicals. You only add the constants that are multiplied in front. So in this case, we would add the 3 plus the 14, which gives us 17, and then of course repeat the radical. So here's our answer, 17 radical 5. Let's do one more, but with dealing something other than square radicals. Let's try with cubes. So what if we had 5 cube root of 80x minus 3 cube root of 270x. Now keep in mind though that as far as having the same index, that means having the same index inside and also being of the same power root. So you wouldn't be able to combine, say, the square root of 5 with the cube root of 5, even though they have the same index. Because they're not the same power root, you wouldn't be able to combine them. In this case, we're dealing with both cube roots, so we can try to make the index the same in order to subtract. So let's start with 80x. I'm going to repeat that 5, and then the cube root, we got to be able to break this up into at least one of the numbers needs to have be be a perfect cube. And what would pop into my mind would be 8 times 10, because 8 is a perfect cube. But don't forget, the x also is not a perfect cube, so that has to go along with the 10. So our 8 is our perfect cube, and doing multiplying times 10x, because those are the leftovers, so to speak. So the cube root of 8 is 2, so it would be 5 times the 2. And then we just rewrite whatever's left over. In this case, it's 10x. So now we want to try to get a 10x inside of our index for the second part. So we're going to rewrite that 3. And let's try to think of a number that's a perfect cube that goes into 270x. My first guess would be 27 times 10x, because 27 is a perfect cube. 27 times 10x would give us 270x, and the cube root of 27 is 3. So we have the first 3 that was given, times the cube root of 27, which is 3, and then we have left over cube root of 10x. Now both our radicals in each portion of the expression are cube root of 10x, so then we can multiply our constants in the front and then just simply subtract them. So on the left hand side we'd have 5 times 2, which is 10, times our cube root of 10x, minus the 3 times 3, which is 9, times cube root of 10x. Okay, so now we can just subtract our coefficients, 10 minus 9, which is 1. So the 1, you don't need to write it down, it's always assumed in the front of the radical. So then our final answer will just simply be cube root of 10x. And that's all you need to do, is just to make sure that your root of your radical in both pieces is the same, as well as then trying to break it down using distributive property to get the same exact index inside the radical as well. So thank you for visiting the NJIT website. If you need any further assistance, please feel free to stop by the CAPE, or the Center for Academic and Professional Enrichment, located in Kupfrian Hall, room 200. Good luck in your studies.